All right, Algebra 2, welcome to your 6.5 to 6.7 quiz review video here. Going to be the first grade, I would imagine, of quarter 4 in a few weeks. Honors Algebra 2 took that quiz today, did very, very, very well. So let's hope get a similar result. All right, simplify. We will not have a clean jailbreak here. The square root of 54 is nothing special. 54 is 9 and 6. 9 is 3 and 3. There is a pair that breaks out. The square root jail. Okay, so 3 goes on the outside. 2 times 3, 6 stays on the inside. And again, I'm looking for pairs of x's because I have the square root. So 2 goes into 14 7 times exactly. So the only thing that remains is the 6. On 28 here, I want the square root of 28. 28 is 4 and 7. 4 is 2 and 2. 2 goes on the outside, 7 stays on the inside. This 2 goes into 7. If I have 7 x's, I will have 3 pairs and 1 left over. Number 3, the square root of 64. 68. 4 and 17. 2 and 2. There's my pair. 17 is prime. It stays on the inside. This 2 goes into 7 for the x 3 times with 1 left over. This 2 goes into 11 5 times, and the leftover 1y right there. All right, what else we got? Number 4, square root of 50. 50 is 25 and 2. 25 is 5 and 5, so 5 goes on the outside, 2 stays on the inside. This 2 goes into 12 6 times exactly. This 2 goes into 11 5 times with 1 left over. We've got the cubed root of 64. The cubed root of 64 is 4, so that makes a clean jailbreak there. 3 goes into 11 for the x's 3 times with 2 left over. If I have groups of 3 with 11, I would have 3 groups of 3, and 2 would be left over. 3 goes into 13 4 times with 1 left over. This leftover jail, we call it, is the cubed root. Make sure the 3's up there. And the last one of this kind, the cubed root of 84 is, in fact, if 81 is 3. 3 to the 4th is 81. 4 goes into 25 times exactly. 4 goes into 17 4 times with just 1 left over. Y to the 1st is left over, and it is inside the 4th roots, not the square root, but the 4th root. All right, number 7, I need to break down root 12. 4 and 3, 2 and 2. Root 12 is 2 root 3. So 6 root 3 minus 4 root 3 plus 2 root 3 is 4 root 3. Square root of 24, 4 and 6, 2 and 2. Root 24 is 2 root 6 plus 54, 9 and 6. 9 is 3 and 3. 6 is 2 and 3. 2 root 6 plus 3 root 6 is 5 root 6. Square root of 8. 8 is 4 and 2. 4 is 2 and 2. So this 2 goes on the outside and multiplies with 5. 2 times 5 gives you 10 roots. The 2 that's left over plus 18, 9 and 2. 9 is 3 and 3. So 7, multiply it with 3, get 21 root 2. 10 root 2 plus 21 root 2 is 31 root 2. All right, so let's continue here. It's very much like Honors Algebra 2's quiz. 18 times 8 is 144. X to the 5th times x to the 3rd is x to the 8th. Y to the 7th times y to the 9th. Add the exponents. Y to the 16th. Like the first quiz, we're going to have a clean jailbreak here. The square root of 144 is 12. 2 goes into 8 4 times. 2 goes into 16 8 times. On 11, 2 times 4 is 8. X to the 8th. Y to the 10th. The square root of 8, 4. The square root of, 2 goes into 8 4 times. 2 goes into 10 5 times. Six times 3 is 18. X to the 7th. Y to the 10th. 18 is 9 and 2. 9 is 3 and 3. 3 goes on the outside. 2 stays on the inside. This 2 goes into 7 3 times. 1 left over. This 2 goes into 10 5 times exactly. On 13, we got 3 times 5 is 15. 3 root 5. 15 root 2. Then 3 root 10. I went out of order there. There's the 3 root 10. There's the 15 root 2. You have conjugates on 14, same two terms with opposite signs. So I just need to do the first. 8 times 8 is 64. And the last, negative root 3 times positive root 3 is a negative root 9, which is minus 3, 61. That should be an easy one. There. All right, in order to get rid of roots, I need to multiply the top and bottom by the conjugate. We see what conjugates do here when we multiply by the conjugate of the denominator. So I need to multiply by root 7 plus 2, the opposite sign. Up top, you're going to have 4 root 7 plus 8. Down below, root 7 times root 7 is 7, minus 2 times 2 is 4. 7 minus 4 is 3 in the denominator. Down below, I'm going to multiply top and bottom by 8 minus root 3. Up top, that's 96 minus 12 root 3. Down below, 8 times 8 is 64 minus 3. 61 is your denominator. All right, then we get into a relatively easy page here. So it might start off harder and get a little bit easier. So write each in radical form. I am taking the 5th root of x squared. I am taking the 7th root of x to the 4th. I am taking the 4th roots of x to the 1st, and I am taking the 8th root of x to the 5th. 21 going the opposite way. This is x to the 4 sevenths, x to the 8 thirds. Make sure these exponents look like exponents. Make sure they do not look like this. It does not look like an exponent. All right, this is x to the 3 over 1. No, that's the 2nd root, x to the 3 over 2. And this is x to the 1/5. Simplify fully, all right? If I'm multiplying with the same base, I add the exponents. These are all fifths of some kind, so I can add them up. 3 plus 7 plus 6, x to the 16/5. Add them up here. I got the same base, so I can add the exponents. 7/4 and 9/4 is 16/4. Which is 4. X to the 8 over 10 times x to the 15 over 10. Add the exponents, x to the 23 over 10. And we keep rolling. 28 here, I can subtract the exponents. 7 minus 5 is 2. 2/12 there, which is x to the 1/6. Again, simplify fully. Get to be the same denominator for your fractional exponents. So 1/4 is 3/12. 5 minus 3 is 2. 2/12 again is 1/6. 3/4 and a negative 3 over 2. Common denominator is 4. So x to the 3/4 divided by x to the negative 6 over 4. 3 minus a negative 6 is 9/4. X to the 9/4. Take the square root of 729, that's 27, then take the cubed root of it, that's 3. Take the square root of 625, that's 25, then take the square root of it. X to the 2/5 times x to the 3/4. 2/5, that's 18 over 20, 3/4, that's 15 over 20. Now add the exponents, x to the 23 over 20. I need to raise both sides to the 3rd power. Not multiply by 3, but raise it to the 3rd power. X minus 1 is 8. Add 1 to both sides. Very important that I add 4 to both sides first. I got to get that cubed root, square root, 4th root all by itself. Then I can cube both sides. When I cube a cubed root, x plus 3 just falls out. 5 to the 3rd is 125. X is 122. 36. I'm going to add 5 to both sides first. Now I got that square root all by itself, so I will square both sides. It means 3x minus 7 is equal to 64. 8 squared is 64, not 16. And then I keep solving. On 37, I need to subtract 3 from both sides. I get the square root of 5x plus 1 is equal to 6. I'm going to square both sides. 5x plus 1 is equal to 36. On 38, I'm going to subtract 4 from both sides. 3x plus 2, being raised to the 1/2, that's, you're taking the square root of it. So again, square both sides. Raise both sides to the reciprocal power. 7 squared is 49. 3x plus 2 is 49. All right. 139 here. I'm going to add 3 to both sides. Again, 1/2 power is taking the square root, so I'm going to raise both sides to the second power, square both sides. That means 2x minus 1 is 16. X is 17 over 2. Number 40. Divide both sides by 5 first. The square root of x minus 1 is 5. Now I'm going to square both sides. X minus 1 is 25. X is 26. And on 41, I need to subtract 2 first. Then I need to divide both sides by 3. Then I need to square both sides. All right, I can get negative answers. That is fine. And that is it, folks. That is your quiz review video, 6.5 to 6.7. This is Yak Math Video signing out.